As I'd said in previous lectures, really to study Mars, we need to go to the surface of Mars. And the Viking landers did a fantastic job with the surface of Mars. And then finally in the 90s, the Mars Pathfinder with the Sojourner rover went to Mars and kind of reinvigorated the modern studies of Mars. So this was kind of a new technology right here. Other missions followed, some successful, some not so successful. The Beagle 2, for example, the British one didn't work. And then the Mars exploration rovers, which landed 2004, Spirit and Opportunity. And they landed in 2 spots on Mars, Meridiani Plains and the Gusev Crater area. Gusev Crater was interesting because we thought that maybe water had flowed into there, and the Mariani Plains are near the outlet of the Valles Marineris. Not right at the outlet of the Valles Marineris, which would have been a great place to look for the possibility of life, but close to there, right at the outlet. It's too rocky to safely land. And the way they landed was not very precise. And so again, the Spirit landing site here, and so it landed near the crater there, and then the Opportunity, and it actually bounced. You can actually see where it bounced and then rolled to a stop and then opened up. From Spirit and Opportunity, Spirit, you can see in that picture right there, those smooth markings are some of the bouncing spots where it hit the ground and bounced. And then Opportunity, now here's the thing, Opportunity bounced and rolled into a little small crater. And so at first they're like horrified that they were in a little crater, but it was a shallow enough crater they could crawl out of it. But the most exciting thing is that this crater actually cracked the surface, and so they could actually look and see the crater walls had layers in it. Now this is a big deal because layers of rock are put down at different times, meaning that successive events built these layers. So whatever was making the rocks, whether it be sedimentation or volcanic activity, it happened over time. And so you're actually able to study a little bit of a time lapse as to what the past of Mars was like. As they looked close at the layers of rocks, they found those tiny little nodules in there. Those little nodules, which they temporarily just called blueberries, not knowing what to call them, turn out to be mineral replacement nodules. Now, what does that mean? It means that you have a water-soluble mineral, and it's dissolved in water and replaced by other minerals already dissolved in water. Now, this is a slow process, and it happens over a very long period of time. That means that it had to be wet there, very wet, for an extended period of time. And that the water that was there had to have been around long enough to have minerals dissolved in it. And so that suggests an extended period in which there were wet conditions. That's one of the necessary byproducts for life. Well, both of these rovers, were able to crawl around and investigate various other sort of things. So it crawled out of its little crater it landed in, crawled over to another little crater, crawled across to another crater, and analyzed things. Considerably more crawling around and rolling around than was designed originally to do. These things lasted for a very long time. The idea was that they would last for months, and instead they lasted for decades. Now, it was not without, incidents. They were crawling around looking at different rock features and so forth. And again, they were lasting much longer than they were intended to, and so things started breaking. And then one of them died, then another one died. Again, dust laying on the solar panels there tended to degrade the operations, made them realize that solar panels might not be the best way of doing things on Mars, and unless you're not planning on being there a long time. Phoenix Lander landed in the northern plains where it's really smooth, and the speculation was that's like a frozen ocean or something. And in fact, it landed. Now the problem is it landed so far north that when the ice cap advanced, it covered this and crushed it. But it landed in the northern plains. Had a variety of different instruments on there that kept running until eventually it quit working as it got too cold as the winter progressed. And interestingly enough, there were, by the time it arrived, there were several other spacecraft on Mars. Mars has been continually visited for the last couple of decades. There's been continuous presence there with orbiting spacecraft, more orbiting spacecraft, landers. So Mars has been under continual scrutiny for some time here. And the Phoenix lander was photographed on the way down, deploying a parachute to slow it and then actually landing. And the interesting thing is it saw this structure, and that structure looks almost exactly like permafrost structures do on Earth. And so again, suggesting that you have frozen ground underneath. In fact, it reached out and scraped the soil and uncovered white stuff. Now, they were trying to argue what the white stuff was. It gypsum? Was it salt or whatever? But as they were looking at it over a few days, it started to go away. Well, that suggests it was sublimating, going from solid into gas. This can actually happen below freezing because when it snows, sometimes even if the temperature doesn't get above freezing, the snow goes away, it sublimates, goes from ice back into water vapor. And so this suggests that they had uncovered ice. So in fact, they're now thinking that much of that soil that they saw was actually dust that had ice mixed in with it, like permafrost. Okay. The entire northern region appears to be almost like a frozen ocean. So what we found was that from these findings that Mars had abundant water. The water had been there for a long time. The Mars surface was very rich in minerals. It does appear to be salty. Salt is also makes the water conductive electricity. That also turns out to be very important for life. The water did appear to be somewhat acidic, so that was some question as to whether life could exist in that acidic water. The water is still there. Mars is very rich in water. There is a lot of water, but it's frozen as ice. The Martian soil is rich in oxygen. It's reddish. Oh, well, duh. Okay, so you have reddish soil, that's iron oxides. It's almost too rich in oxygen. For example, Phoenix found perchlorates. This is excess oxygen minerals. So this is like peroxide, hydrogen peroxide. In fact, they believe that's why the labeled release experiment did what it did with the Vikings, is that it's almost like hydrogen peroxide, a very reactive chemical in the Martian soil, and then that reacted with the nutrients they put in there and released gases, not life. Now, this is good news and bad news. It means that there's a tremendous amount of oxygen on the surface of Mars locked up in chemicals there, which are probably very easy to get the oxygen out of. In terms of manned missions to Mars, that means we might not have to take oxygen there. We've got to have oxygen to get there, but once we get there, we can extract oxygen from the soil. That's good. In a search for life, it's bad. Too much oxygen turns out to be toxic. Hydrogen peroxide is used as an antiseptic. So this suggests that maybe the soil at present is actually inhospitable to life, at least to most forms of life. And so that's another interesting finding there. More recently, the Mars Science Laboratory, which actually uses a radiothermal generator, which I'll talk about in later lectures, to provide energy, was targeted at Gale Crater. And right near the center of Gale Crater is this rather odd mountain called Mount Sharp, and the rover is going to climb up Mount Sharp. It has been climbing up Mount Sharp, stopping at different layers and analyzing things. Preliminary findings that they are finding is that Mars, in fact, was very rich in water, extremely wet. And the water was liquid water for an extremely long time. The water was not too acidic for life. And the organic molecules that have been found, because we're now finding some organic molecules, indicate that Mars had all the chemistry for life. That does not mean that they found life, but they do find that Mars had all the right chemistry necessary for there to have been life. And it had liquid water. The isotope ratios in the Martian atmosphere are very similar to the isotope ratios they found in the Venus's atmosphere. Indicate that, as we expected, Mars had a thicker atmosphere, and the atmosphere ablated off into space. So there's possibly what happened is that since Mars, is smaller and cooled off quicker, probably has a much smaller core. The iron is more diffuse in Mars throughout the whole planet rather than concentrated in the core. So the magnetic field is weaker and then went away rather quickly. This would suggest that there's very little protection from solar wind and cosmic rays, which allowed them to help ablate and dissipate the atmosphere. Also, Mars being very close to the asteroid belt means you have impacts. The impacts can also blow away the atmosphere. As that happened, the atmosphere being very rich in CO2 would have had a huge greenhouse effect, which kept Mars actually warm. So as the atmosphere started going away, Mars cooled off, and much more quickly than, for example, Earth would. So in the distant past, Mars was very wet and had the conditions necessary for life. But as it cooled off, the water froze and trapped some of the CO2 in the water. Okay, remember the oceans can become carbonated, but it traps the CO2 into the water, and so it doesn't release it as necessary to keep Mars warm. So this is like an inverse greenhouse effect. So it actually ended up trapping the CO2 in the permafrost and allowing Mars to get even colder. And then as the atmosphere ablated, it got even thinner atmosphere, and then the boiling point of water dropped down to the freezing point, and so you end up, again, trapping the atmosphere, trapping the CO2. And so Mars's atmosphere is so thin, it doesn't really hold in the heat at night at all. It gets super cold. And so that, again, that is actually the wrong way to go if you want to keep a planet habitable. So, as I said, we don't have evidence yet whether life was there or not, though our latest mission to Mars is going to be looking for biomarkers. It is going to be looking for evidence there may have been life on Mars. We definitely think that Mars was way different than it is today and was possibly habitable. There's a big step from being habitable to being inhabited.